Righto, boys, let's have a look at this exam practice question. So let's highlight key terms. It's a cubic function. Okay, so we know it's an x cubed. Stationary points are located at 0, b, c, 0. So we know that they're turning points. Okay, so what does that mean? So given that the point at C is an intercept and a stationary point, it's going to be x minus c all squared. At A, we have an intercept, so it's going to be x now minus A. Now, the key there is, even though A is over here on the negative side of the axis, we're calling it positive A. They've called it positive A. So the intercept is at x minus A. And the y-intercept at B. So we know then, so let's call, so first things first, the linear factors. So x minus c, x minus c, x minus a. So they're my factors. Find the values of x for which f of x is greater than or equal to 0. So f of x is obviously my y value. So I want to know whereabouts is the graph greater than or equal to 0. Not equal to, strictly greater than 0, which means hollow dot all the way through here, the y value is positive. To there, hollow dot, the y value is positive. So what does that mean in terms of a domain? We need x, well, let's instead of using that, let's interval notation. So we're going to go round bracket from A to C, round bracket C to positive infinity. Okay, with a union in between. So the key is at C itself, it's equal to 0, so it's not greater than 0. So what's the last part saying? Where is the function less than or equal to 0? Solid dot down, solid dot. Yeah, so both those sections. So we're going to have from negative infinity to A inclusive union. What are we going to do there? Oh, we'll just put a little bracket, union C. All right, so that's where it's less than or equal to 0. All right, write down the rule for f of g of x, so it doesn't ask us to prove it exists or anything like that. We just need to substitute g of x into the function f. So f of g of x is equal to, there's the function f, there's my g of x, plus 2 times the function x, which is x minus 1. So now we can just write that as f of g of x equals just 1 over x minus 1 plus 2x minus 2. For 1 mark, we'd probably get away with that. Okay, so don't try and do anything clever with simplifying or grouping or anything like that. All right, let's have a look. Find the inverse function of f. So straight away we know my final answer is, let's get that one. My final answer is going to say f inverse is equal to, all right? So find the inverse, we swap our x and y's. So let's put x equals 3 over y plus 2 minus 1. Take the 1 across, x plus 1 equals 3 over y plus 2. Bring the y plus 2 over here. Take the x plus 1 back onto the other side. Y equals 3 over x plus 1 minus 2. So there's my y equals. So let's just write it in the form we need to. F inverse of x is equal to 3 over x plus 1 minus 2. Let's go back and check. It's just said to find the function, nothing about domain and range. So all good. Let's put a square around that. 3 marks. Give me 3 marks. All right, what have we got here? Find the rule for f of g of x. Again, no proving that it exists. It's a 1 mark question, so let's keep it pretty simple. It's part B of the same function. So I've got f of g of x is equal to f of x is 3 over x. X in this case is going to be x squared minus 4. So there's x plus 2, don't forget minus 1. So then f of g of x is going to be equal to, we'll just write that as 3 over x squared, negative 4 plus 2 is minus 2, minus 1. 1 mark, that's all we're looking for. Don't have to worry about anything nice or clever. Flying along here, lads. On the axis below, sketch the graph of h of x, label any asymptotes and their equations. So we should be hoping for questions like this. Shifting at 2 units to the right, shifting at 1 unit up. So let's put our asymptotes in and label it. Oh, let's not put it there though. We should put them in, but try to put them in the correct spot. So at x equal to positive 2, we have an asymptote, and the horizontal asymptote is at y equal to 1. Okay. It's a positive hyperbola. Look at the domain. From 2 to infinity, so I only need one section of the graph drawn, don't I? So that section of the graph is just going to be here. Label any asymptotes, sketch the graph. From 2 to infinity is just the positive section of the graph. Fantastic. All right, find the rule in the domain of the inverse function for h inverse. So clearly, that's a 1-to-1 function. So it does exist. We weren't asked about that though. So what do we want to do? Let's put y, we won't put y, we'll put x equals 1 over y minus 2 plus 1. Take the x across, so the 1 across I should say. Minus 2, bring y minus 2 is equal to 1 over x minus 1. So then we'll end up with a y equals 1 over x minus 1 plus 2. But of course, we need to finish that with h inverse. The x is probably optional. 1 over x minus 1 plus 2. Quick check, find the rule and the domain of the inverse. So we need the range of the original. So the domain of this graph. Now let's have a think about it, because the original graph was restricted, wasn't it? Domain of h inverse of x is equal to the range of the original. The range of that graph is from, what do we got, from 1 to infinity. So we'll give the domain here is just that section of the graph, 1 to infinity. Well, good.